Hey everybody, this is Larry. This is me going with Q2 of the bi-weekly contest 93, maximum star sum of a graph. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So I think the hardest part about this problem, and I took a little bit of a time on it, and I had a silly mistake, so we'll go over that in a second. I took a bit of time on this because I think I was just trying to prove the bounds, and this is where having strong fundamentals help. But really, it's not that it's not that hard of a problem implementation wise, perhaps, but it and I did actually, to be honest, even at the end, worried a little bit about the complexity, but I actually didn't think I have that much to worry about. But I was that's what I mean by having strong fundamentals about analysis. Because basically the tricky part is that n is 10 to the fifth, and even there's edges are also 10 to the fifth, but you have to be really careful in terms of how you think about it. And for me, for example, if you do, like, let's say y is the number of edges and you do a y times k algorithm, well, that's obviously going to be too slow because that's 10 to the 10. However, that is actually not possible because, well, we'll talk about it in a sec. But there's basically, first of all, this is basically my code. Basically, I construct a list, but I didn't even have to construct a list. And you can maybe do this with a heap and just keep on appending, same idea. But the idea here is that I just create a list of all the values of all the adjacent things, and then I sort each of them in reverse order, and then I just take the best out of the sum of the first k of them, assuming that they're greater than 0, because then they always give you better elements. So I did get a wrong answer because I missed that it was at most k. I thought it could be, or I thought that you're forced to take k elements. So silly mistake there for 5 minutes of penalty. But yeah, so like, this is O of n and this is sum of k elements, so this is O of k, right? So why is this not n times k, and why is it not timeout? And I did worry about this, like I said. The short answer is that there are only n edges, right? Oh, sorry, there's only y edges. So because there are only y edges, and because you could say that on each edge we look at it on both sides, right? There are two nodes on a connecting two nodes connected by one edge, right? So that means that each value will only appear twice, as you can see here. Each value will only appear on the value of the node twice. So that means that even though this goes to k, or it looks like it goes to k, it really goes up to how many number of edges it has, up to k, right? It means that the total amount of all the nodes, all the ends, if you sum up all the number of, if you count the number of things that are in y, the variable y, there's going to be 2 times the number of edges at most. So that means that you're only really summing up 2 times y numbers. So that means that in total, this is going to be O of v plus y, right? For this part. This is also O of y, so yeah. So it turns out that this part is the most expensive part, and you could maybe implement it with a heap to get a little bit faster, but it's fine. So this is going to be O of n log n, or v log v. E log E, actually. Sorry. The reason is because if you think about it as all the edges as one list, and you sort it, it's going to be E log E. And if you break it apart, it's only, the sum of those things is going to be strictly less than E log E, and so is E log E. So the total complexity of this is going to be O of v plus E log E time, and O of v plus E space. And that's pretty much it. That's all I have for this one. Hope that it makes sense. Basically, you're looking at, I don't think I actually explained the problem that well for this one. My fault. I think I was just jumping into this the explanation. But the idea here in code is that you take the value, and then all the up to k non negative or positive even up to k positive values and then sum it together to get the maximum star sum. And because this number is the star sum of this node, so then now you just sum over it. That's pretty much all I have for this one. So let me know what you think, and you could watch me solve it live in the contest now. I can just find. Summarize what was in star graph. Okay. What does that mean? The star sum, okay. Oh, star, okay. What? It's okay, it's 2. Okay. Okay. Let's see. Does that include itself? Okay, it does include itself. Okay. Is that too slow? Could be too slow. No, because each edges can be. No, but then each edge can. That is too slow, isn't it? And then I mean, do a heap on each item, but that's ridiculous. Maybe. Because each one could be heavy, and then. Complexity wise, that makes sense, but it seems so slow. Maybe I'm just I don't even need this actually. That could have been a heap. But well, we'll see. Let's see. don't know if this is going to be fast enough, to be honest. Thank you for having a negative example. That would have been a stupid. That would have been a stupid negative 5 minutes. I don't know if this is fast enough, to be honest. Hope so. Oh, Oh, at most K edges. Wow. Okay. Well. Man, bi-weekly chose violence today. Still may time out. I don't even. Okay. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and this video, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.